Hello everyone, we will discuss about polar effects part 3 in this video, which is nothing but mesomeric effect or resonance effect. In our previous videos, we had a discussion about the polar effects, part 1 as inductive effect, part 2 as an electromeric effect. Now we will discuss about the mesomeric effect in this video. What is mesomeric effect? Simply, mesomeric effect is otherwise called resonance effect, which simply called the flow of electrons from one part of the pi conjugated system to other part of the pi conjugated system. So within the ring system, simply if you consider about the benzene ring in a example, if the benzene ring is there, what about the substitutions presence there? So based on the substitution, how the electron is displacement takes place in the benzene ring system. So which is simply called as a mesomeric effect or resonance effect. So I am repeating here the definition: the flow of electrons from one part of a pi conjugated system to the other produced by the resonance. This is called resonance effect or mesomeric effect. It is symbolized as M or R effect. M stands for mesomeric, R stands for resonance effect. As usual, this polar effect is also classified into negative and positive effects. So negative mesomeric effect or negative resonance effect is simply called as the displacement of electron towards the group. See, for the example, we have nitro group, carbonyl group, nitrile group, acid group. Like these groups are present in the benzene ring, which is responsible for electron displacement towards the groups takes place. So that this effect is simply called as negative mesomeric effect or negative resonance effect. And other category is the positive mesomeric effect or positive resonance effect. Here it is nothing but the displacement of electrons takes place away the group. For example, if the OH group, Cl group, OR group, SH group, SR group, NH2 group, NR2, like these substitutions are present in the benzene ring, which is responsible for the electron displacement away the group takes place. So that this is called plus mesomeric effect or plus R effect. So in the next slide we will discuss about the how the displacement takes place. For example, I am giving you here NH2 substitution and OH substitution in this slide. So this is responsible for the positive resonance effect in the benzene ring. So see that both of them having a lone pair of electrons. So what will happen, the positive resonance effect? Here the substitution releases or donates the lone pair of electrons to the benzene ring, so that the electron density is increases to the ring. So we should keep remember here, in the case of our NH2 group or OH group present in the ring, the lone pair of electron is transformed to the benzene ring. So C double bond N as well as C double bond O here forms as a immediate transfer of the electron, so that the OH, O or N gains the positive charge because these are the donors. And once it is accepting, this carbon gains a negative charge. So we should keep remember that in the plus R effect or plus M effect, the benzene ring which carries the negative charge towards the all the places. So that this is our simple idea to remember the plus R effect. So if suppose this ring substitution is present here, this position is ortho, meta and para position, your meta position, and you have your ortho dash positions are there. So the electron displacement is takes place to your ortho position, to meta position, to para position, like the transformation of the electron displacement takes place. So that this electron displacement is simply called as an plus R effect or your plus M effect. So as a whole, the electron density is increases in this system. So what will happen to our negative R effect here, negative R effect or negative M effect. So for example, there is a nitro group present here. So this nitro group withdraws the electron from the carbon. So as usual, we know that the electronegativity is there, or these groups or withdraws the electrons means, so the presence the carbon bond here, so this electron, the pi electron is shifted towards the C double bond N, so that what will happen here, there will be C double bond N forms. So since it is donating, so it becomes a positive charge. So it is accepting, so it goes to the displacement and negative charge is transformed here. And we should keep remember here, in the case of our minus R effect, the entire benzene ring system is having a positive charge. So the positive charge is towards the entire benzene ring, displacement takes place. So that as a whole, if positive charges come over here, which implies that there is electron density decreases. So we should keep remember that in the case of your plus R effect means, I will go back to the previous slide here. If it is a positive R effect means the entire benzene ring contains a negative charge because of electron density is increases. In the case of our negative R effect, that implies that electron density decreases, that means that gains the positive charge. So we should keep remember that if you writing the entire resonance structures of benzene ring here, the positive charge, if you keep it positive charge towards the benzene ring system, which implies the minus R effect. Reversely, we should keep remember. If suppose positive charge is there, it is a negative R effect. If it is a negative charge is there, it is a plus R effect. So that you should keep remember that. So based on this electron displacement, what will happen generally about the system, the resonance structures are come over there. Based on that, which one is stable, more stable resonance structure, that is helpful for any kind of the chemical reactions for the applications towards the our resonance effect or mesomeric effect. So I have come across with what the informations I want to pass on, that I have just conveyed here. Thanks for watching this video. Like it, subscribe it and share it among your friends for more such videos in the chemistry platform. Thank you for watching this video.